So let me first apologize for the background music. It is completely to do with what's her name? Margot has been trying to sing Christmas carols, so now they're stuck in my head. I'm really sorry. Christmas carols in October, not appropriate. But here we are. All right, so find Sasha's rate in miles per hour for each part of the route. So here's the thing. We want miles per hour, and they give everything in minutes, which is kind of tricky, right? So we have to convert this into hours, or we can solve this using ratios. Let's use ratios for now. We know that we get 5 miles in 20 minutes, and we need to scale this up to 60. Which I multiply 20 by to get 60? Well, 3. Same thing, multiply by 3. So we get 15 miles per hour. So for stop 2, let's try the same thing. So we have 8 over 24 is equal to blank over 60. Now, 24 is not going to 60 evenly, but 8 goes into 24 evenly, right? This is what I mean by being able to work both ways. 8 goes into 24 3 times, so if I multiply 8 by 3, I get 24. So I have to work backwards and divide by 3, so this has to be equal to 20. So we're in 15 miles per hour. This would be 20 miles per hour. Now, unfortunately, stop 3 is not quite as pretty as the other ones. All right, Adam Sandler is great and all, but we're going to wait. Michael, can you hold off for a second? It's going to be a bit. Okay. All right, so here we can try the same thing. We can go 15 over 40 is equal to x over 60. Well, 15 does not go into 40 evenly, and what do I multiply 40 to get 60? Well, that's a little bit easier, right? I would multiply by 1 and 1.5, 1.5, right? So my scale factor is 1.5. So I'd have to multiply this by 1.5, and I would get 22.5 miles per hour. So obviously the fastest section would be between stop 2 and stop 3. So then, all right, suppose you can maintain a steady rate of 13 miles per hour on a bike. How long will it take you to travel the same distance Sasha traveled in 1 hour and 24 minutes? Now, this one is a little trickier. And this is what's been giving generations of 7th grade connected math students fits. So let's take some time on this one. So if I'm maintaining a steady rate of 13 miles per hour, I'm going to make a little table just so I have a ballpark answer so I can figure out if things make sense. So if I have time and distance, so at 0 hours, I'm going to go 0 miles. 1 hour, I'm going to go 13 miles. 2 hours, I'm going to go 26. 3 hours, I'll go 39. So if I go back up, let's figure out how far Sasha goes, because that's how far we're going as well. 5 plus 8 is 13. 13 plus 15 is 28. So we're going a total of 28 miles. 28 miles at 13 miles per hour. So, if I'm going 28 miles, where is that going to fall in the table? Well, that's going to be just after 2 hours, right? Because 26 is close to 28. So I know it's going to be really close to 2 hours, just a little bit more, right? So, let's try to figure this out. How did I go from this to this? Well, I multiplied the time, multiplied it by my rate of 13 miles per hour. That gave me the distance, right? So using this logic, by the way, for those people who remember, this is a very common equation that is tested on CSAP. Rate times time equals distance. 28 is my distance, right? So time times 13 is equal to the distance of 28. Well, what's the opposite of multiplying t by 13? Dividing by 13. So I divide by 13, divide by 13. And so I will have t is equal to, I'm not going to do that one in my head, so I have 28 divided by 13, and I will get 2.15 hours. But who in their right mind talks about time in 0.15 hours? No one, right? So we have to convert this 0.15 minutes, or hours, into blank minutes. Now there are a couple ways I can do this, but the simplest is to think about it this way. How many hours in a minute? Sorry, how many minutes in an hour? Well, there's 60 minutes in an hour. So if I multiply 60 times 0.15, I will figure out how many minutes I have. So let's do that. So I take my 0.15 and I'm going to multiply it by 60, and so I get 9 minutes. Now, if I really want to get technical, it's about 9 minutes and 15 seconds. So his time is going to be equal to 2 hours, 9 minutes, and approximately 15 seconds. This conversion process here is something that is very commonly tested for entrance exams, placement exams, proficiency exams. So it's something that you really need to understand. So question D, suppose you're racing him. So he went, anytime now, he went 28 miles in 1 hour, 24 minutes. Well, we need to find our answer in miles per hour, right? This is hours and minutes, so I need to convert this into just plain hours. So I need to work backwards. So what is 24 minutes is equal to how many hours? Well, in our other conversion, we multiplied by 60. Here, we're going to divide by 60 because we have 24 sixtieths of an hour. So 24 divided by 60 is 0.4. So this is equal to 1.4 hours. So remember our equation that we talked about in the previous part. Rate times time is equal to distance. So I don't have my rate, but I have my time. So rate is times my time of 1.4. It's going to equal my distance of 28. What's the opposite of multiplying r by 1.4? Well, dividing it. So I'm going to divide everything by 1.4, and I'll get my rate. So 28 divided by 1.4 is 20. I would have to maintain 20 miles per hour to tie him. So this tends to be a fairly complicated problem for 7th graders, but really it's not too bad if you think about it in terms of ratios and making sure your units match with everything else. I hope this was helpful, and have a wonderful evening.